Hey, hi everyone. Can everyone hear me okay? I hope everyone's minds are weaponized and everything. I hope everyone's ready. So my name is Alex, but you can call me Alex with double quotes. And I hear some of you wondering, what's with the double quotes? Why would you do that? It's very simple. A long time ago, a bunch of journalists wrote about me, and they referred to me as a hacker who goes by the name Alex in double quotes. And Alex is also my real legal name. So, and I learned nothing from this because more recently, a bunch of journalists wrote about me when I found former Australian Prime Minister Tony Abbott's passport number and phone number online, talked to him about it, and did not get arrested, and they referred to me as a hacker, in double quotes, whatever that is. I also have a story about CHUCON. Picture this. The year is 2016, and this is the only picture I have of me at the very first CHUCON doing magic tricks in my talk. Don't worry about it. But it's good to be back here again. I also help out organizing another conference called PurpleCon, which is a conference that instead of looking like this, looks like this. But enough about me. Let's talk about work. Professionally, the most recent job I've had is doing red teaming, and I probably shouldn't have put it in double quotes actually, but and I hear many of you wondering what is that. It's very simple. You have to hack the company that you work for, or the company that you're doing it for, exactly like an actual criminal would. Like research who they are, do exactly what they would do. And the company doesn't even know it's you doing it because you're that accurate. And then afterwards, you show them how you did it because a real hacker doesn't show you what you missed. And then finally, you sell the stolen data on the dark web for big money because that's what a real criminal would do. But no, not really. You don't do that. Once I was doing this exact slide at work and something went wrong and like the X didn't show up and I had to, I was like, no, you got to believe me. I think they did. So professionally, I've worked doing red teaming at many companies, such as Atlassian. Anyway, now I don't work there anymore, and now I work at Nowhere because I'm engaging in business ventures and at my new business, Mango PDF Communication, where I teach hackers how to talk and write good so that all the not hackers actually understand us. If you've seen me do a talk before, you know what you're in for. If you haven't, don't worry. I'm a professional communicator. You know how Luke was saying before, like something, what is it, 2 minutes per slide? So I think that means 2 minutes per slide. This talk is 30 minutes. That means the optimal number of slides is, I think, 220. Yeah, okay, good. I'll see you there. Let's do it. But enough about work. Let's talk about malware. Let's talk about what we're here for. Have you ever written code so bad that you've wondered, at what point does this count as malware instead of software? Hello, and welcome to my talk. You probably have heard about malware, and you've probably even seen it, some of you, and probably some of you have even stopped it or detected it. But what about, have you actually used it and operated it? Or what about, have you tried to hide it from people who are trying to catch it? Or have you tried to make the malware look like it's coming from an actual criminal, not a red teamer, that's you? Have you tried to perfectly act exactly like an actual criminal? Let's talk about these things today. That's what I want to talk about. But first, I just want to get something out of the way, because everyone's got different definitions. What actually is malware? What does that count as? Or what counts as malware? Malware is a Steam video game in which you need to navigate Windows installers and try and click the next button without accidentally installing, malware. My name is Alex, and I recommend downloading and installing malware on your personal device. Very positive. How good is that? No, okay, so not really. Malware, the way I like to explain it to people is that malware is like remote control software. So it lets you remote control somebody else's computer from your computer. It's kind of like you can SSH into their computer. It's not exactly like that, but that's how I think about it. When I explain to software developers, it's like the hackers can SSH into your computer. They're like, oh no, that's bad. I'm like, exactly. Why would you use malware? Why do I care about that? Why would anyone use malware? Well, maybe it's because you're a cyber criminal and you have things to do and you need to use it for stuff. How good is this picture? I love this picture. Or maybe you're not a criminal, but maybe you're someone who needs to act exactly like one, doing adversary emulation, which is formerly known as red teaming. The reason it's formerly known as red teaming, by the way, is because what used to happen is someone says, hey, let's do red teaming. And they're thinking, yes, I will perfectly emulate and copy the known cybercriminal group Scattered Spider. And the other person is like, yes, let's do red teaming. And they think that means lockpicking or breaking into somewhere. Anyway, sorry, that's why we don't say red teaming anymore. Well, that's why I'm trying not to. Back to malware. Why would I use malware? There's actually two main reasons. The main reason, the first most common reason, is because getting past two-factor auth. These guys, we've seen these people before, they work. They are they're not perfect, but they work pretty well. And hackers generally can't get past them. Maybe the SMS, but generally they can't really. And so, but what if you know how on people's laptops they have Google Chrome or something installed? or if you also have malware on that computer, what if you just like use the malware to upload their Google Chrome to your computer, and then you open like gmail.com, but when you open gmail.com, you've copied their Google Chrome, so you actually logged in as their Chrome, and you don't even have to log in, you don't have to do two-factor auth, you're like already in, because you've copied over all their browser cookies, all their sessions, all that stuff onto your computer. That's like the most common reason I've seen it used. And because this is like really good, right? There's all this, like the login screen is so hard to get past, but what if you just waited for them to log in and then you were just already logged in? Way easier. The other reason is getting past zero trust or VPN or all that networky stuff. Kind of the same reason, in that it works, you can't get past it otherwise, and this is the easiest way to do it. So, for example, if this works for zero trust or VPN, when you connect to the zero trust server, which is totally different to a VPN, you need like your email and your password and maybe like a YubiKey or two-factor auth, and you need a special device certificate. Like these are hard things to get. And then when you actually connect to it, then when you actually connect to the zero trust server thing, you send all that information there, and it goes, should I let you in? Yes, okay, actually we'll let you in. And then after that, you can talk to the stuff. You can talk to the production network. And so then, meanwhile, me out here trying to do hacking, I'm like, can I talk to the production network? And it's like, who are you? You don't have all the stuff? No. So fair enough. That means it works. That means it actually works. But meanwhile, you're like, well, this person over here, they can connect to it. So what if I have malware on their computer, what if I just use that malware to proxy all of my computer's network traffic through their computer, so it goes all the way around the world like that. And then when the zero trust service sees my traffic, it's like, that's fine, so true, that's fine, you can come in, you're that same computer we saw before. So like that's the other reason people do it. Anyway, it's good, is what I'm saying. Like, malware is good. There are other reasons too, like you can get the files off their computer, of course, but these are the main two reasons. All right, now that we know, this talk's called Let's Make Malware. So now that we know why we might do malware, let's try and make it. How hard could it be? I don't know if anyone's made malware before, but how hard could it be? Our pop quiz, is this malware? This is like, oh, well, I'm stealing someone's SSH keys, and then I'm like exfiltrating them, maybe, to a file. Is this malware? Kind of. But like it takes their SSH keys from their computer like to their computer. But like meanwhile you're like over here being like, why did I do that? What was the point of this? Like, so like no, that doesn't count. First try, but like no, that's not malware. Okay, what about this idea? Like the thing I was saying before about SSHing into the computer. That's pretty good. Can we actually just SSH into the computer? This is when at the very beginning. This was my first idea. I was like, wait, can I SSH into their computer? And then I'm like, okay, so SSH. Oh, I see the problem because like what do I type? Because like, what do I type after that? Like no one has like a publicly routable like SSH server running on their laptop. Actually, probably some of you do have publicly routable SSH servers running on your laptop, but like I don't want to hear about it. Like, please keep it to yourself. So okay, no, that won't work. So what do we actually make the malware? What if instead of all that stuff from before, we have a whole other server involved, a whole other computer involved with some like domain name, like crimecentral.com, and then we put the malware on their computer, its code, and then it goes and asks that computer, like the malware control server, let's call it, what do I do? And it says, hey, you should execute this command, which we pre-program the server to say that. And then it goes, okay, look, I found this SSH key, let me send it to you. And then meanwhile, I connect to that server and say, great, what did my malware find? Give me the key. We did it, that's malware. That's like a really basic version. But I hear many of you asking, like, okay, that would be nice if you just had software that did that, if you had the malware, and if you had this malware control server, where do you actually get this malware from? I mean, there are many ways, but one thing that real attackers and red teamers both do is just download it from GitHub. There are like many open source malware frameworks out there. This one's made for red teamers, but real hackers love using stuff made for red teamers because it makes them look like red teamers. Like, think about it. So this is just some random one that I found called Sliver, and it says, blah, 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 it says this nerd stuff. The important thing is it says, oh, look, I can generate new malware. That's pretty good. This says, hey, the new malware should use HTTPS as its like communication channel thing, and that's like generally the one everyone uses because that blends in with everybody else. And it says, this is the malware control server name. This is where the malware should talk to. And then it says a bunch of nerd stuff. I don't know what this means, whatever. And then, yay, we did it. It makes a new malware thing. And you can it makes a file on your computer, and then you can put it somewhere. And like, yay, we did it. We made malware. That was easy. But there's like a very key step here, which I'm sure you're wondering, which is like, you make the malware on your computer, and then like, how do you get it on the other person's computer? That's like a whole thing. Isn't that what a lot of our jobs are about, is making malware not be on our computer? So how do you get it there? And listen, I just want to get something out of the way. Social engineering isn't that hard. Everyone makes such a big deal about it, but you just got to keep it simple and clean, right? Look at this. Like, there's no way that's not going to work. I don't know why everyone makes such a big deal about it. It's fine. Simple and clean works every time. So let's assume that worked, and now some person's running our malware on their computer. Love it. So as soon as they run the malware on their computer, then the malware talks to the malware control server, and it's like, hello, I'm here. And the server's like, great, welcome. Why did I make this slide? We did it. We made malware. So okay, the end. Great talk. I hope everyone had a nice time. We did it. We executed malware. Isn't isn't this what we're trying to stop? Like, I feel like a lot of people say, for a lot of people, I feel like the story ends here. They're like, oh no, we got compromised, we got remote code executed, and that's bad, and then it's over. But like, that's not the end of the story. When you're the person actually driving the malware, you're like, wait, we need to keep it there, and we need to like do something with it. We need to use it to commit some sort of crime. Like, that's what we're doing. We're being cyber criminals. And those steps are harder than just getting it there. For example, just as a very simple example, what if the person runs the malware because we told them to, and then they're like, oh, okay, but I want to use my terminal now, so I'll just, okay, good, Control-C, and then you're just like, oh, whoops, like, I didn't think that far ahead. Okay, so let's try again. Let's make malware again. Okay, so I know what you're thinking. Like, let's just background the malware. Let's just background it. And like, yeah, that does work. Then they can press Control-C. It puts this awkward number here, and if you're trying to be sneaky about it, they're like, why is this number printing out? But also, even if you background it, what if they're like, all right, well, I'm done with this. I'm just going to close the terminal window now, and then it's over. Suddenly the malware it's not running anymore. Your server never hears from the malware again. It's very sad. Because when you run the malware, it's like a child process. It's a child process of the bash process. And so when you get rid of the bash process, it also gets rid of the child one. That's how it be. So you have to put this, or one way is to put this disown command after the ampersand, still puts out the number. But now, instead of being like this, the bash is like, whoa, I've never heard of that malware process in my life. I don't know who that is. So like when you get rid of this one, when you get rid of the bash process, the malware's still going. You close the window, and the malware's still there. Yay, we're good now. That's like things you learn doing red teaming, things you learn doing malware every day is things like this. But also, what about this number that's getting printed out? Like, don't we want that number to not get printed out? What if we actually try and disguise this malware as something else? You would absolutely hate to run a command that's not meant to print anything, and then it just prints out a number like that. You'd be like, ooh, what did I just do? You know? So how do we hide that? I know what you're thinking, oh, let's redirect everything to dev null, let's put standard in and standard out there. I tried that, nope, doesn't work, still prints out the number. So I was eventually just like, okay, it's fine, just let's put more dev null redirects on it. And now it does work, love that. I think you actually don't have to do the second one because the first one's like a subshell or something, but that's some like nerd Linux thing that I don't understand, so it's fine. So okay, we did it. Now can we check this one off? Absolutely no, we cannot check this one off. Because what if this person who's running our malware on their computer, they don't know they're running it. So what if they're like, you know what? I think I'm going to restart my computer just to feel something. Yeah. And then they do, and then our malware's running, and it's fine, and they restart their computer, and we have not like made our malware start again when the computer restarts, and so it's just over. So, oops. Let's try again. You've probably heard of this part. This part's called the persistence part. Has anyone heard of this file before? Or similar, there's also called bash profile. It's like bashrc or zshrc, but not. It's like slightly different. Basically, it's the same, but people don't really look in this one. And so inside this one, you could put the whole malware command thing in there, but that's a bit like, what if they do look in it? You know, like they probably won't, but what if they do? If you were to open your like bashrc and see that, you'd be like, ooh, that's not good. So instead you could put this in there. That looks much more legit, doesn't it? But like, what is this? Who would do that? These people at NVM, they would do that. NVM is a like very popular software for managing your versions of Node.js that you have, because apparently there's so many Node.js versions, you need like a version manager software. And what do you do if you want to manage versions of NVM, actually? I don't know, is there an NVM? I didn't think about that. I don't know. But anyway, they do this, and what this command does is it does some nerd thing, not important, but the important thing is it executes some other bash script. And no one's going to look in that bash script, so that's where you put this part. So now that looks way more legit. This is not by any means the perfect persistence method, but it is one. So now we can check this off and say keep it there, because now the malware will stay there forever. Except also, no, it won't. Because you know how we're using this malware, what if we want to hack more than one person? We can make 3 copies of the malware and send it to 3 people, and they all install it because the social engineering is flawless, and then eventually, say, for some reason something happens and one of them is checking their node version manager or something, and they notice that something's gone wrong, and the cyber police, incident response people show up, and they're like, hey, there's malware in this computer, and these people are really, really good at like finding something, an indicator of compromise, I guess, on one computer and saying, where else have we seen this? So they're like, hey, are any other computers here talking to crimecentral.com? And you're like, oh, and they're like, oh, yes, they are. Look, we found more copies of the malware. And then they all get lost. So does anyone know the solution to this problem? Anyone thinking of it? Yeah, that's right. The solution is to go outside and touch grass and forget any of this ever happened. No, not really. I'm just kidding. The solution is redirected infrastructure. Let's talk about redirected infrastructure, no going outside. So what if instead you had another computer in between the malware and the malware control server? And this one has some cool and normal domain name that blends in much more than crimecentral.com. And it's using an HTTP reverse proxy to go and talk to crimecentral.com. That just means it's like transparent. You can't tell it's actually talking to that server. It looks like it's coming from that server. now that we have the server in between, oh wait, before we get there, I imagine you're all wondering, like, wait, but where do I host the server? Like, you could host it on AWS like everybody else does, but like, I mean, firstly, like cyber criminals, they don't always do this, because AWS is, I think, kind of pretty good at like giving your credit card to the government and detecting when you're a criminal. Or you could sign up for some extremely legitimate offshore DMCA ignored hosting provider that I found. This is the first one I found. This one's called Alex Host Unrelated. Unrelated. So yeah, use any hosting provider, and now you have this server that looks very legit. And for real, if you use AWS, everyone's like, well, that's probably red team. There's no way hackers would really do that. And anyway, the point of making this redirector server is you can make a lot of these very easily and very cheaply. And so you make every single person gets their own unique bespoke redirector server. So that way, when they find one of them, they can't work. When the incident response people find one of the things being compromised, they can't just check the domain name and find every other one. So when they show up, they're like, oh, okay, the first one's oh no, we found this computer's been compromised on the left, and like it's going to get contained or whatever happens to computers. And then the other ones are still okay. But are they though? Because what was wrong with this one? The thing that was wrong with this is that they were all using the same thing, right? They all use the same domain name. But aren't they all using the same, what's wrong with this? Aren't they all using the same malware? Like, yeah, totally. The way we have it set up now, they're using the exact same like malware. And so wouldn't you, so that way when people show up and they say, oh, where else have we seen this hash running? Where else have we seen this binary running? Same problem, and they all get burned again. So you've got to go back, got to regenerate all the malware, make them all slightly different, put all the different domain names in them, or change them in some other way. So now they're all unique. Now they're different hashes. And now when one of them gets caught, okay, you get the idea. So now we can say we kept it there. Except actually, not only can we not say that, we actually haven't even done the first step right. Because you don't just want to execute the malware for anybody. You only want to execute the malware for the exact right person that you're aiming at. Let me explain. So remember this part? You know how like every time you want to hack a new person, you have to make new malware, new domain name, new all that stuff? This is like a lot of work. This is like, and these things all need to be perfectly unique to each other and not share any like file names or like hashes or like domain names. And so it's a lot of work to like manage all these and test them all. So it's expensive to make them. And so you know how currently we're doing this is how we're hosting our malware is on this GitHub thing, and we're just like, do you really just want to put the like actual raw malware binary like right there on GitHub? Like, what if for some reason the social engineering doesn't work, or someone's slightly suspicious of it, and they like just click on the thing and be like, wait a minute, that's malware. That's not something else. Like, that's kind of bad. Don't you want to be a bit more subtle than that? It'd be easy for the incident response people to just see this and be like, that's definitely malware. So one way. And when they do find it, or if they do find it, they learn a lot of things. They learn, oh, you're using this malware framework, whichever one it is. And so anywhere else, if they see any other hackers using that same malware framework, they'll be like, is that the same people as before? Which is bad. You don't want to do that. You want to seem like somebody who's not you. They also learn what's the redirected domain name, what hosting provider do you use, and all those things. You want those to be as unique and different as possible, so they can't tell that it's actually. You want them to think they're being targeted by like this elaborate gang of like international cyber criminals that are all different and all unique, rather than it just being you every time. So, and I hear many of you wondering, what's the solution to this? How do we solve this problem? That's right, it's to do staged payload design. So instead of, remember, you know how before we're doing this, how we're just downloading the malware straight from GitHub? What if we didn't do that? And instead we downloaded a malware downloader. Now we're talking. This has got to be good. So now you download the malware downloader from GitHub, and then that actually downloads the malware from somewhere else, some sort of malware hosting server thing that you make and you control. And then after it downloads the malware downloader, then it downloads the malware. And then your malware does its normal thing, same as before, et cetera, et cetera. And so, okay, and so the thing, because the malware takes such a long time to make, you might want to, like, it's really important that they don't get that malware, and they don't, like, it's really important that that is not attributable to you. It's really important that it's different to every other copy. So one thing that some people do, if you're thinking that this is like really paranoid to do it like this, here's an even more paranoid way of doing that. So instead of your malware, when your malware downloader downloads something from the malware downloading server, see, it's easy, it probably makes some request. Maybe it's get. Probably not /malware, probably something more subtle, but imagine. It has to have some sort of user agent that it makes that request with, if it's an HTTP one. And it's really good if you make it with this exact user agent. I'd be amazed if anyone could tell why it's this exact user agent. But the reason is because here are the actual user agents, here are the actual versions of the Python requests library. There isn't a 20.30.1, it doesn't exist. That's not like possible. But like, did anyone see that and be like, excuse me, Alex, that version doesn't actually exist to Python requests? Like, of course not. And so the reason you want to do that is because probably it's unlikely that someone else is going to accidentally have that same user agent as you. So that way, this malware hosting server can check the user agent of whatever's trying to download the actual secret malware payload from it and say, okay, if you've got the secret password, it's basically a password, this user agent, If you've got this secret user agent, then you can have the malware. But if you don't, then you can have some other normal file and be like, this isn't a malware server. Like, it probably is kind of obvious that it is a malware server, because it's like, why are you downloading and executing this file then? But at least they don't actually know, they don't get the payload, they don't know your secret techniques or whatever they are. For example, if the malware, you're actually framing it, if you're actually like dressing it up as a backdoored VPN client, if they use the right user agent, you can give them the actual VPN client that's backdoored, but if it's not, you can just give them the normal one that's not backdoored, and then it's much more plausible that like your thing is not actually downloading malware. Okay, so now check, can we keep it there? Actually not really, actually no, you can never really be sure that it's going to be there. There's actually a lot of problems with this malware. There's actually a lot of problems with this whole thing we've talked about. Like, the malware isn't really obfuscated enough, like it is a bit, but you can totally reverse engineer it. And also, there's no SOX proxy ability in it. How do you SOX proxy through it? And also, the malware doesn't run in memory, so they can totally check what's going on just by checking all the disk writes. And also, you should probably not do the Z profile thing, that's kind of a bit cringe. What about you have to do some fancy new Electron app backdooring technique thing, and the malware hosting server, where's that hosted? Shouldn't that be on CloudFront or some legitimate thing? There's actually a whole bunch of other problems with this malware. It's far from perfect. And I hear many of you wondering, what's the solution to this? How do we solve all these problems? That's right. So go outside and touch grass and forget none of this ever happened. Thank you very much.
I am a super genius.